A geopolymer concrete by partial replacement of fine aggregates with plastic waste. Abstract. The use of Portland cement in concrete construction is under critical review due to high amount of carbon dioxide gas released to the atmosphere during the production of cement. In recent years, attempts to increase the utilization of fly ash to partially replace the use of Portland cement in concrete are gathering momentum. Most of this byproduct material is currently dumped in landfills, creating a threat to the environment. We can reduce the pollution effect on environment by increasing the usage of industrial byproducts in our construction industry. Geopolymer concrete is a concrete in which Portland cement is fully replaced by fly ash and GGBS, ground granulated blast furnace slag. Geopolymer concrete is a new material that does not need the presence of Portland cement as a binder. Instead, the source of materials such as fly ash, that are rich in silicon, Si, and aluminum, Ai, are activated by alkaline liquids to produce the binder. Hence it is the concrete with no Portland cement. The present study covers the use of plastic waste in geopolymer concrete as partial replacement of fine aggregate. Sand is replaced with plastic waste at 5, 10, and 15% respectively. Alkaline liquids used in the study are the solutions of sodium hydroxide, NaOH, and sodium silicate, Na2SiO3. Molarity of sodium hydroxide, 10 m, is considered. Fly ash and GGBS were used in different combinations and percentages respectively. This study is conducted to know the compressive strength of geopolymer concrete with plastic waste and to compare the same with geopolymer concrete without any replacement of fine aggregate. Keywords: geopolymer concrete, CO2 emission, GGBS, plastic waste, fly ash. Introduction. For the construction of any structure, concrete is the main material. Concrete usage around the world is second only to water. The main ingredient to produce concrete is Portland cement. On the other side, global warming and environmental pollution are the biggest menace to the human race on this planet today. Combustion of fossil fuels to operate the rotary kiln is the largest source, and other one is the chemical process of calcination limestone into lime in the cement kiln also produces CO2. In India about 2,069,738 thousands of metric tons of CO2 is emitted in the year of 2018. The cement industry contributes about 5% of total global carbon dioxide emissions. But the demand of concrete is increasing day by day for its ease of preparing and fabricating in all sorts of convenient shapes. So to overcome this problem, the concrete to be used should be environmental friendly. To produce environmental friendly concrete, we have to replace the cement with some other binders which should not create products, as binders can reduce the problem. In this respect, the new technology geopolymer concrete is a promising technique. In terms of reducing the global warming, the geopolymer technology could reduce the CO2 emission to the atmosphere caused by cement and aggregates industries by about 80%. And also the proper usage of industrial wastes can reduce the problem of disposing the waste products into the atmosphere. Geopolymer concrete is a concrete in which Portland cement is fully replaced by fly ash and GGBS, ground granulated blast furnace slag. Geopolymer concrete is a new material that does not need the presence of Portland cement as a binder. Instead, the source of materials, such as fly ash, that are rich in silicon, Si, and aluminum, Ai, are activated by alkaline liquids to produce the binder. Hence it is the concrete with no Portland cement. Objectives: to understand properties of geopolymer concrete in order to use it as alternative for ordinary Portland cement. To draw conclusion on whether geopolymer technology can provide an appropriate alternative for Portland cement. Compare the strength of geopolymer concrete having partial replacement of fine aggregates with normal geopolymer concrete. Use of plastic waste as construction material and reduce the problems of disposing plastic waste and industrial byproducts. Methodology. Kamlesh C. Shah Sovereign conducted research on strength, restrictions and stability and durable of fly ash-based geopolymer concrete. In this study, two concrete mixes are to be controlled out: GPC mix 1 fly ash concrete and OPC mix 2. Concrete mix consuming OPC conforming to amount of cementitious material used in GPC mix 1. Dissimilar attentions were used, such as alkaline liquid to fly ash ratio of 0.40, 0.45 and 0.50, ratio of NaOH to Na2SiO3 2.0 and 2.5, molarities of NaOH, 10 m, 12 m, 14 m, and 16 m, and check the compressive strength. Compressive strength and durability test were achieved under ambient temperature curing. He regulate that fly ash-based geopolymer concrete have an admirable conflict to sulfate attack, salt attack, and acid attack as connected to ambient curing. Minor increase in the mass of any bad effect on environment. The use of industrial concrete cube due to preoccupation of sulfuric acid and salt for concrete. Benny Joseph and George Matthew allotted the steering of mixture contains of aggregate content on the engineering assets of geopolymer concrete. Impact of other limitations such as curing temperature, dated of curing, ratio of sodium silicate to sodium hydroxide, ratio of alkali to fly ash and molarities of sodium hydroxide were also conversed. Created on the study accepted out, it can be determined that a geopolymer concrete with appropriate proportioning of whole aggregate content and ratio of fine aggregate to entire aggregate, laterally with the ideal values of other parameters, have better engineering properties than the corresponding properties of ordinary cement concrete. As a consequence can obtain the expansion properties achieved by geopolymer concrete than ordinary concrete. Rashida Mohammed Hamidi, carried out the impact that combination of alkali matrixes intricate consumption of aluminosilicate materials and alkali activators as the central starting materials where the preceding could be fly ash, sodium hydroxide, NaOH, and sodium silicates, Na2SiO3, correspondingly. It will be further labeled the consequence of NaOH attentiveness towards the possessions of fly ash-based alkali formation. The stimulus of NaOH attentiveness in the range of 4M to 18M was analytically studied using Fourier-convert infrared spectroscopy, FTIR, for structural elucidation, scanning electron microscope, SEM, to detect the morphology and purpose of the mechanical assets. Flexural strength was approved out by universal testing machine. Based on the consequences achieved, the optimal NaOH attentiveness, 12M, at which alkali revelations the best mechanical possessions was attained. Urvashi Khandelwal, during this study, cement has remained and replaced by fly ash and the assets such as compressive strength, sulfur resistance, acid conflict, water absorption, sorptivity, and chloride attack have been considered. Class F fly ash has sustained and geopolymer concrete was heat cured for 24 hours under 75°C. It was distinguished that use of geopolymer concrete not only regulates its greenhouse gas but conjointly increases its strength and resistivity to detrimental acid. Sulfuric acid attack also causes deficiency in the compressive strength of alkali concrete, the extent of degradation be contingent on the absorption of the acid fortitude and the amount of exposure. Abdul Alim and Aramaraj projected an optimal mix for the alkali concrete. They conveyed that the alkali concrete accessible high demonstration with reference to the strength and that high early strength was attained in the alkali concrete mix. The increase in proportion of fine aggregates and coarse aggregates increased the compressive strength up to the optimal level. Alexander Rodrigue, José Duchesne, for an suitable air void system, good mechanical belongings and low permeability micro exceedingly in alkali activated binder systems, appropriate slag fly ash proportioning, water and admixture substances are needed. Air in training admixture quantities of up to 10 times the optional dosage were necessary to obtain minimal air void properties similar to what is needed for normal Portland cement concrete subjected to freezing conditions. Collective added water caused in emergent absorption and decreasing crack counts in concrete. Increasing fly ash insulation resulted in increasing preoccupation and decreasing early age crack counts. Increasing both added water and fly ash content caused in less autogenously shrinkage. Geopolymer concrete with plastic replacement 2019 Department. Results and discussion. Compressive strength. The compressive strength of fly ash-based geopolymer concrete specimen with GGBS 10, 20, 30, 40% replacement and different percentages replacement of plastic for 14 days and 28 days. Test results for partial replacement. Average compressive of fine aggregates. Compressive strength of geo with plastic, in strength for 14, strength for 28. Polymer concrete percentages, days, in MPa, days, in MPa, mix F90 G10 100% sand 14.95 19.43. 95% sand plus 5% plastic 15.2 21.78. 90% sand plus 10% plastic 14.13 18.31. 85% sand plus 15% plastic 12.93 17.12. Graph 7.3 Comparison between compressive strength at 14 days and 28 days with 5% replacement. Conclusions. 1. The strength of geopolymer concrete at 5% replacement of fine aggregates with plastic increased as compared to that of geopolymer concrete with 0% replacement of fine aggregates. 2. As the percentage of replacement of fine aggregates increases after 5%, the strength of geopolymer concrete decreases. So it is advisable to replace plastic up to 5%. 3. Geopolymer concrete with 100% replacement of fine aggregates couldn't attain proper strength, i.e. we got 4.5 MPa, hence complete replacement will not be possible. Future scope. Ground granulated blast furnace slag-based geopolymer concrete can be investigated with other source materials which include rice husk ash, kaolinite clays etc. Development of high-strength geopolymer concrete manufactured with silicates and hydroxides of potassium can be tested, and effect of high-strength in flexural behavior can be studied. More usage in real constructions can be implemented. Plastic, which is one of the reasons for global changes, can be reduced by using again in geopolymer concrete. Geopolymer concrete which is already green by addition of plastic, it will be best solution for global and climatic changes by producing less carbon as cement is not used, by reducing the disposal problems of industrial byproducts, and by reusing plastic as a construction material.